All right, this is going to be the video for homework 4, which is our flywheel. This one is going to be going over some new commands. So we have this disk that has 3 equally spaced through holes, and these are countersunk. So you can see here that we have this angle on these holes. So these are countersunk holes, and we have just a 1/4 inch hole through the center there. So let's go ahead and get started. All right, so remember to change the role to advanced, start a new file, create a model, make sure that we have a model selected, it's in inches, name the part correctly, save it to a location you can access later, hit OK. So for this one, we actually have a round part. So we wouldn't use the whole command to make this part. What we're going to do is create a sketch, and we're going to create a circle. That's going to be the first thing that we do. So we're going to come up to our left-hand corner, create a sketch. We'll go ahead and create it on the top plane. Hit OK. And we'll come up to, and we've done profile, we've done rectangle. Now we're going to use a circle. Now, just like with the rectangle, we have some different ways to create our circles. The first one is circle by center and diameter. So the first click would be where the center of the circle is at. And then our second click is going to be the diameter of it. So you can see as I move out, increase in diameter. And then I'll just click again to create the circle. The other way to do it is by 3 points. So my first point is not going to be the center. It's just going to be a point on the circle. I'm almost making a triangle here. And between those 3 points of the triangle are where the circle is going to be. So my first point, second point, and then third point, see how it's defining where that third point is at, and that defines our circle. Typically, the one we use the most is that first one. So we want to click on the center point of our circle, and then the second click is going to be defining the diameter size. Now, I want to put it at the origin. So again, we can use our snap points, make sure the pointer to curve is turned off, or we can just hover over the origin and select it. And I'm not going to care about the actual size right now. I'm just going to put a circle there, and I'm going to exit out of the circle command. And we have one movable curve. So to define the size of this circle, we're just going to click on it, see how it highlights red. That's what we're going to click on. You see it's actually 12 inches in diameter right now. We are told that this is supposed to be 3 inches in diameter. Ask what to scale it down. Yes, I do. Now, before we exit out of this sketch, let's look back at our drawing. So we have this outer diameter, and then we have these 3 countersunk holes here, equally spaced. And we're told that they lie on a diameter of 0.75, and they're equally spaced on that diameter. We could use the method that we have used for creating our holes so far, where we create a hole, and inside that hole command, we create our point, and that is where our hole is located at. We're going to use a slightly different method. So we're going to create that point in this first sketch that we have created. Remember, this is 0.75, this diameter is, so it means the radius is going to be half of that. Now, we don't have to use any math here. We don't have to pull out a calculator and write this out. We can use NX for that. All we need to know is that this point lies half of 0.75 from the origin. And so that we're going to add a point. So I'm going to come up here to the point, And I want this point to actually be on this line. So I'm going to put it on the line. And I'm going to dimension this half of that 0.75 from our origin. I'm going to click on that point, click on the origin. And when I click to make the dimension, instead of giving it an actual number, what I'm going to say is equals 0.75 divided by 2. Divided by is just that slash. And then I'm going to hit enter. And it creates a parameter here. So that's P0 equals the 0.375. We'll look into what the parameters are later on when we talk about parametric modeling. As you can see right now, it's highlighted. It says parameter 0 equals 0.75 divided by 2, and tells us here that is 0.375. This method, it's helpful that we don't have to do any sort of math for any of this, but it's equally as nice that when we're looking back, let's say we didn't even model this, maybe we're looking at a model that someone else created, but they used this method, they should be able to go in and realize, oh, well, that 0.375 was half of the 0.75 that was called out in the drawing. So that's another reason to use this method, so we can actually see how we came about these numbers. So we've got this positioned, and whenever we put it on that line, we put a constraint on it. So the constraint was that it was on that axis, that vertical axis. So we have a fully defined model right now, or a fully defined sketch right now, and we can go ahead and hit finish. And the next thing that we want to do is actually extrude this. So we'll come up here to extrude with our drawing selected. And if we look at our drawing, this is supposed to be 0.118. We'll hit OK. And if we flip it over, we can still see our point. And this is where we are going to put our holes at. We're actually put it on this face. So let's go ahead and do our centered hole, that 1/4 inch hole. So for this one, we're just going to come up to the hole command. We want a simple hole. This is going to be 0.25 inches in diameter. There's no start or end chamfer on this. For the specified point, I'm going to go into the sketch section. I'm going to select that top face, or that face right there. Hit OK. And I want this point to be on the origin. So what I'm going to do first is I'm just going to click over here somewhere. And very similar to what we did with the step block, I'm not going to dimension this. All I'm going to do is I want this point to be where the origin is at. And I'm going to use a constraint. Remember to make sure that we have create persistent restraints turned on. A good indicator is that you actually have these extra constraints here. But I want a make coincident. I want to be able to select 2 points and have them be on the same point. So select the motion curve or point, the one that's going to be moving. That's going to be our first point. And then the stationary point. That's going to be our axis point. I'm going to wait for the 3 dots to show up. Click. And I want to select the origin. And I'll hit OK. That point has moved to the origin. And our sketch is fully defined. We can hit finish. Again, this is a through hole, so we want to make sure that we have a through body selected for the depth limit. And we'll select apply. We selected apply because now we're going to create one of our other countersunk holes. So we have 3 holes to create, but we only made 1 point here. And that's because we're going to use another command, another feature that's going to help us create those other 2 holes. But we need to make at least one of the holes. That's why we made one of the points. So we're going to come up here to simple. And instead of the simple hole, what we want is a countersunk hole. This allows us to put a flathead screw into this, and it'll be flush with the surface. So when we choose countersunk hole, we have some other parameters here that we have available to us. So if we look at our drawing, it says 3 times, and we have a diameter of 0.144 through, and then we have this shape here. This is telling us that it's a countersunk, it's countersink, and that angle it's a 0.307 by 82 degrees. So that angle is 82 degrees, and it is a 0.307. That's the diameter at the top. We want to change that hole diameter to the 0.144. The countersink diameter, that's going to be the 0.307. And our 82 degrees angle is going to be here. That's already default, should be default 82 degrees. I want to make sure that also that through body is selected again. And when we specify our point, we don't want to actually go into the sketch like we have been doing. We've already created our point, so we just want to go out and select it. So I want to choose that point, and then we're going to hit OK. Now we've created one of the holes. We need to create the other 2. And what we're going to use is our pattern feature. In other applications, this could be called an array, but for NX, it calls it a pattern feature. So we want to click on pattern feature up here at the top. The very first thing, as you can see that we've got these this red kind of asterisk here, and you've seen these for all the commands that we've done. You see this red asterisk, this red pom-pom. This is asking for information. This is NX's way of telling us that it needs information from us. It needs us to select a feature. And the feature that we want to select is going to be our hole that we just made. We're going to select that hole, that countersunk hole. And you can see now that red pom-pom is turned into a check mark, a green check mark. It's saying that we're good to go. Now, the rest of this information is to describe how this feature is going to be patterned. So the pattern feature takes one component, one feature, and then patterns it the way that we describe it to be. So the layout right here, right now it's linear. So it's going to go in the X direction. It's going to pattern that, copy that feature in the X direction and the Y direction. We don't need that. So we're going to click on this drop down. We have a whole bunch of different selections that we can choose from. We want to choose circular because we want this feature to be patterned around this center axis. So when we choose circular, a couple other pom-poms appear. Under rotation axis, we need to specify the vector and then specify the point. So if we click on specify vector, you see this these purple arrows pop up. This is one way to do it. We can specify the actual vector, and the vector is just the direction, whether we're going to use the positive z, negative z, the positive x or the negative x, positive y, negative y. That's what it's asking us, the direction that it's moving. We could select one of these arrows, and then we can select the center point that we want it to move across. Or we can select both. So we could select our z-axis, and that's going to orient it. That's going to choose a vector and a point for us. So now we don't even need to select a point. But let's go back and let's select just one of the vectors. So let's choose the positive z vector. So I've chosen the vector. Now I need to select the point. So the point is going to be the center location. So the center point that this feature is patterned around. And for us, it would be the center of the circle. It would be the origin of our sketch because that's what we've created the circle around. So we just want to be able to, we want to select the center point here. Let's choose the arc center. So our vector has been selected and our center point has also been selected. And you can see that there's these cubes that have appeared. These cubes are the center point for the feature. So right now we would have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 features, 12 holes that would be created. And that's because of the spacing that we have selected. So if we come back over to our pattern feature window, we can come to spacing. If we click down this drop down menu, we have count and pitch, we have count and span, we have pitch and span, and then we have list. So count and pitch is going to be the number that we have, or the number that we want copied. So we want 12 copies here, and it's going to be the pitch angle. So the angle between each of these locations. So between here and here is 10 degrees. If we do count and span, again, we have the number that we want. So the count, 12, and then the span angle. So what's the angle from the beginning to the end point? You can even see this right here. That is the angle that we have, the 110 degrees. And we also have the pitch and span. So that is, we don't have a count. It's just the angle between each of the locations and then the span angle that we have. So for us, we're told that we have 3 holes that are equally spaced around the center point of this part. So we want count and span. So our count is going to be 3 because we have 3 holes, and you can even see that now we have 1, 2, 3. And our span angle, we want this to go all the way around. So it's going to be 360 degrees. Now if we look at the cubes, they look about where we want them to be. Another feature to some of these windows, the commands that we've been choosing and using, we have talked about the OK, apply, and cancel. We haven't talked about the show results. What the show results does is it shows us our results, but doesn't change any of the parameters that we have here. So we can undo those results. Maybe I forgot that, maybe I accidentally put in, 320 degrees. I can show the results and, well, that's definitely not right. So I haven't actually committed to anything yet. So I could change that back to the 360, and I could say show results and say that looks right. And then I can hit OK or apply. And that pattern feature is nice, especially with the design intent of the part. If we have 3 equally spaced holes around the center of our parts, then that's the design intent of it. If we need to change the size of the hole, then all I have to do is go back and change the hole size of the one that we created, and the other ones will change as well. So the design intent of this part has driven the fact that we have used the pattern feature command. So another thing to point out real quick is if you're in a command and you need some help on it, you can hit F1. F1 will take you to some helpful videos, some other helpful information on how to use this feature. So that has been it for this assignment. Make sure that you turn it into Canvas, and thanks for watching.